Um, I've got a couple of things I want to cover. I'll just list them out first.
Mhm.
I want to show you what I found with distributed GPU calculations and the performance thereof.
Mhm.
I want to talk to you about the progress that I've made with that new stuck loop,
Mhm.
and in particular, a few edge cases that are particularly interesting,
Mhm.
and talk about where I want to take the interface or the workspace and how you and I can reconnect, or what prompting means in this
Yeah.
new model. Um,
Cool. Cool.
yeah. Hot diggity! I got my computer back.
Hey, it's back.
Hey, yeah, okay. So, apologize for the interruption. Just give me a little
Yeah. You
tick.
just need to sacrifice a chicken to the great god Bill later on.
I would have sacrificed so much more. I got, you know. So, alrighty. So I went back to this little list here. I just
Yep.
wanted to reorient, make sure we're still talking the same thing.
Yep. And this is a
M&A's.
prioritized stack rack, isn't it? So let's check it. M&A, yes. Jitters, yes. AI attribution for rapid cooperation. Yeah. Sure. Yeah. Stocks per minute, yes, absolutely. GPU chain, yeah. Okay, that all seems still relevant. Yeah.
Yeah. Okay. All right. So, and this one is a little bit different because there's a bit more depth for that now. There's
Mm-hmm.
stocks per minute, but also thanks per minute, I think matters as well. Like, what's the ratio of um, stocks versus thanks
Mm-hmm.
is some sort of a
Mm-hmm.
weird, sort of a way to
Yeah.
describe the mode of the network.
Yeah. Um. Yeah. Thanks is a situation of having something solved.
Right.
So it's somewhat similar to what we were saying the other day, which was uh, everything is a stuck.
Mm-hmm.
And there's an emergent property. So thanks are essentially an emergent property of,
Mm.
or a state rather, let's give it a better term, of stock being sold. But yes, okay. Yeah, we
Mm.
can talk about that.
Okay. All right. So we're in agreement that these are still the main things to be done. Um,
Yeah.
Trying to figure out the base architecture of what HAL looks like with the stuck loop strangely
Mm-hmm.
seems incredibly important. Like, it seems like getting that right defines how everything else gets done, because
Mm-hmm.
it changes what we do for work. Like, what does work look like in this system? What needs to be done, and how does it get distributed around to the people that need to do it? And just a great deal many things, actually. So I'm actually thrilled with the current design, but actually the main reason I wanted to talk to you is because I can see how, using this design, I think we can package up the amount of understanding that's required for us to explain the Dreamcatcher can be greatly reduced if we
Mm-hmm.
use this current stuck loop with the concept of making the Dreamcatcher be a a meta LLM. Okay, so really
Mm-hmm.
the main reason for my call is to discuss the statement I wanted to make about what the positioning of the Dreamcatcher is.
Okay.
That's that's why I have.
All right. Um, and yes, Meta LM is a good. Well, it's another way of talking about swarm, right? It's a swarm of agents.
Swarm of agents, swarm of people, swarm of
Yeah,
lots of
yeah.
things.
But nobody gives a shit because all they're interested in is the response coming back from their prompt.
Pretty much,
If
right?
you put your foot in the accelerator, you really don't need to know everything that goes
Yeah.
between,
Oh,
your foot.
yeah, that's right. So also log probs. Um, remember in Sam Altman's presentation, he was going on about alt probs back in November the 7th, and he mentioned it in passing, but he was sort of like, I promise I'll give you guys log probs soon. And
Yeah.
remember that little demo I showed you where it gave you that heat map on the words, and you could click on it and you could see what
Yeah.
alternate. Yeah, yeah.
Yeah.
So
I do. Yeah.
that's been enabled now for GPT-4 responses, so you can get the log prob back. So each word it makes, it'll also give you the confidence score it had in it, and the alternate words that it also considered, along with their probabilities too. And
Mm-hmm.
so what I suspect is able to be deduced from that is that when hallucination is occurring, I suspect that the probability is very low. And so when we get back a log prob that's low as the responses are streaming in, we can detect when the confidence has gone below some amount and then kick off some sort of remedial behavior.
Well, yeah, that's a good thought. Because we've been talking about trigger points.
Yeah.
I'm getting it to say, I don't know. Now, we've never really defined at what level it says, I don't know. Maybe
Right.
it's the whole goal.
We've always tried to work
Goal or
with
whatever.
the whole thing,
Yeah.
and then we've had these
Yeah.
concepts of you take the whole prompt and then you run it through an assessor and you get back a confidence score and all that. But actually, using log probs, we're actually getting it every token, and so
Right.
the principle may be applied, but it could be at a more higher frequency.
Yeah. Yeah.
So,
That would be really cool. That would
what,
avoid quite a lot of pistol whipping, wouldn't it?
yeah, it would
Okay.
be. So I also want to show you. There's going to be a bit of a jumbled presentation. I'm sorry. It's
Nice.
quite reflective
Nice.
of
By the
where
way,
the fuck
time
we're
wise,
at.
I've got as much as you've got.
Okay, excellent, excellent. I'm pleased that you have recovered your state. If there was a
Yes.
dollar value to be put on it, how much did it cost to recover?
3.5 days. So I don't know what the dollar version of that is,
Ouch.
but 3.5 days.
Okie dokie.
Yeah.
Okie dokie. All right. Right. So this was a bunch of. This is a bunch of blogs that I found from some guys that are making a vector database. And the reason I want to show you this to you is because there's one particular guy, this guy. I don't really know who he is, right? But the thing is that he's got a series of blog posts here that actually detail a range of different sorry, I need to work on getting my token rate up when I talk. He's got a range of different blogs that focus on very different ways to improve retrieval assisted generation, or RAG. And so
Okay.
how
Assisted. Okay.
how we're treating goaling is a special type of RAG, like a highly customized RAG, where we're using the goal as the way to retrieve information, which is the helps, and then we're using the helps, and then we're allowing the helps to be upvoted based on how successful the use of them was, were allowing corrections. So you can basically retrieve the document and edit the document in the same cycle. That's why our
Um, can you define how he's using RAG? What's his definition?
RAG. So the retrieval tool in OpenAI is a RAG, um, and he's providing here a bunch of different methods by which you can improve RAG performance. Does that
Okay.
answer your question?
Okay. Okay.
No.
Yes, it does. So he's probably got some kind of assessor in there.
Well,
Imagine.
they have a bunch of benchmarks basically, or evals that they run, and they sort of talk about how it comes back.
Oh, I see. But the evals, do the evals feed back into? Sorry, I just want
The,
to understand what
the
you mean by
evals
RAGs with this guy.
regs are retrieval augmented generation.
Okay.
I think I've missed the point of your question, or yeah, I've missed your question. Sorry, can you help me?
My question is, I just want to know this guy when he's talking about a RAG, is he talking
Yeah.
about well, what's his definition of RAG? Just so that
Um, RAG is defined as any type of LLM improvement that is based on retrieving some sort of context to be passed in with the prompt.
okay, well, that's Simon's OpenAI then. Okay.
It's exactly the same. It seems like a
Right.
a pretty agreed term. So
Yeah.
he's got in this blog a bunch of different techniques by which you can improve your RAG performance.
Uh-huh.
And I've been going through them one by one, and they're quite interesting. Um,
Okay.
Quite interesting. So, for example, this one, re-ranking, was a very simple method that all it does is it simply says, so for our example, we would say we've got this prompt, we generated a goal, we then pulled up
Yeah.
a bunch of goals that are similar in vector space, and then we want to
Uh-huh.
start using some of those to solve the problem, right?
Uh-huh.
Re-ranking is a method of saying, for example, we want the first 20 goals.
Uh-huh.
You get them all back, and then once you've got them back, you pass all of them back to GPT-4 and say, rank these in order of effectiveness for this task,
Uh-huh.
and then you get back the top four. But it's a
Uh-huh.
so you've used the vector search to give the broad cluster,
Uh-huh.
and then you've used an intelligent model to narrow down even further, because the broad search, whilst it'll give you things in the neighborhood or things in the cluster of, it won't give you the best one, as well as
Uh-huh.
passing that 20 into GPT-4 and saying give me number one.
Uh-huh. Uh-huh.
And so that's
Okay.
right, so that's that tactic.
That's quite neat.
It's quite neat. Yeah.
It's just a stack rank, isn't it?
Yeah, but it's reprocessing the results. This was the one that got me on to looking at log probs, because
Mm-hmm.
it's saying that Flare is a forwards-looking active retrieval augmented generation, is a means of
Sorry. Forward. What was it? Go back up. Let me deconstruct that. Forward looking. Okay.
yeah.
Active. Okay.
Yeah.
Retrieval. Okay. Augmented generation. Augmented. What's the augmentation?
So that's just RAG, retrieval augmented generation. But
Okay.
the
Forward
FLA
looking.
part
Active.
is how it does it. And if you just ignore the words for a bit, and I'll show you how it works, and it'll explain it all.
Okay.
What it's doing is that each time it hits some sort of a trigger point, like a low value log prob, where the probability is uncertain, it then takes everything it's generated so far, plus the initial RAG or the retrievals that have come from using RAG, and does another RAG with everything it knows so far. So that in the process of generating one body of text,
makes sense.
it stops at various points and then does more lookup, more retrieval, because it knows more now.
So it's holding it down on as many cycles as you want.
It's re-retrieving, and so how that would apply to us and our goaling, you might sort of get through the task list of how that, because the help is really just a series of steps. You might get down a number of steps and say, my confidence is low. I need to get more goals, or I need to get another goal for solving this particular piece in the help file. Like I've got here, and it said, do I have a CRM? I don't have a CRM. I need to look up the goal that says get a CRM, and then sort of start invoking that help file in the next layer up on the stack, so that you can solve tasks using combinations of previous tasks. And so that's what this type of technique would be like. Yeah, and it was just a really good read on different types of tactics that we can use to improve how the retrieval augmented generation goes for us. Yeah, that's that. So
that's really nice. That's really cool. Lanced B. Okay.
Lanced B. Yeah. So they're just all they're trying to do is they're trying to be a little bit like what we are, but they're trying to. Where is it? They're trying to do retrieval and all this stuff. Here we go. So they want to sort of do this bit, which is what we're doing for the goaling, and then kind of like they sort of want to be us, but in a more traditional DB sense. So that's how I stumbled upon them.
Well, that's not going to last very long.
Yeah. Well, the thing is that the more I think about it, being able to run in a distributed fashion or a decentralized fashion is incredibly useful. And so these guys are always going to be centralized, because as we know, decentralizing a database is a bit of a nightmare. In fact, from our experience, it's a $17 million nightmare. But hey, who's counting? And here we are. And I think it's pretty good when I combine it with the next thing I want to show you in the list of fun things to do when you have decentralized architecture. Yeah, was there any further questions on the RAG stuff?
No, it's good.
No, that's cool, right?
Give me 2 seconds. I'm going to write down that so you don't have to ping across.
Oh, thank you. That's very kind of you.
Okay, yeah, got it.
Alrighty, so the next thing is the one that I am most excited about, actually.
Okay.
Alright, so. Right?
Okay.
Sounds fun, right? Okay.
It does, doesn't it?
What they've done is these LLMs that, I showed you that LM Studio, and I showed you Llama File, and I showed you these other ways to run an LLM. They all have these different layers of training weights in them, and you can load some of them into your GPU or all of them if you have a baller card. But they generally take a lot. So what these guys have demonstrated is they've taken these 3 classes of model, the Llama 2, Falcon 40 billion, and Bloom, which is 176 billion, which seems excessive. And they've found a way to break down those layers into small enough chunks that they can be loaded on a consumer grade GPU and then allow you to connect different groups of consumer grade GPUs that are hosting these little units of layers and
Really?
form a pipeline out of them, right?
That's
So
awesome.
it is awesome. It is absolutely awesome. So
Is
first,
working?
hold your horses, please. I'll get there. So this is effectively the set of nodes, like what you might get on a Tor network, or
Right.
BitTorrent tracker that shows like the health of the server and how long it's been going and all that. So they've broken it up by models. So this is the model that seems to be the most widely distributed. It's called Stable Beluga 2. I think it's like a 40 billion parameter model, from memory. And I wouldn't trust my memory, so let me just look it up. 69 billion parameters. Okay, so it's a big one. So with compression, that would probably run you about maybe 40 gigs worth of RAM in your GPU, which, you know, not everyone's just got lying around. Anyway, yada, yada, yada. So there's a range of different ones that work. Not all of them online because it's an experimental network, but this is the main one I want to show you. Okay, this is it running on the Stable Beluga 2 model, running on a decentralized or distributed set of consumer grade GPUs, where otherwise you would need like an NVIDIA H100 or something like that just to fit that amount of stuff into your GPU RAM. What's a fancy question we can ask it that would be hard?
Hard. Okay. I think. What is the best color for a flight suit if you are in the Air Force for New Zealand?
You took too long, so I'll ask it next.
Oh, okay.
So the token rate there, 3.7 tokens a second. That's sort of comparable to what you get out of ChatGPT anyway.
How does it reconcile the use of the remote GPUs?
Reconcile.
Or is it just literally people just offering it up in order to get?
At the moment, it's just people offering it.
Right.
But when I consider the amount of errors on the ChatGPT API and this one and the speed, this one's actually better. So we'll see. I mean, this is the longest output I've seen it produce, so I wouldn't be surprised if it fails. But
it's a single model, right?
Single model, yeah.
So I couldn't put in the GCHQ IQ test thing into this as an image.
Oh, not multimodal, yeah. No, it doesn't do images. But I think the point they were trying to make is that with a bit of work, you can make all kinds of different LLMs work in a distributed manner. And so I really just wanted to show that, first of all, it's possible, which lays the groundwork for yeah. So I mean, it sort of knows is the point. And
all right, okay. So we got a distributed GPU space.
Yeah.
that's someone's done.
Yeah. That
And
seems, with a bit of effort, it seems able to run almost any large language model that was built using PyTorch or the tensor frameworks or any of those major frameworks. And so, yeah,
yeah, cool. What's the cost of this per token to you right now
free.
doing this?
Free because it's being donated
Right.
by
Okay. But is it
these
actually
kind of
free?
people. It's a demonstration system.
People.
Yeah, it is free.
Are you donating up any kind of cycles
No,
from your laptop?
no, because I didn't connect my GPU. They invite you to,
Right.
but I haven't done that. So
Right. Okay. So they're being nice about it to start with.
Yeah, being nice just to show. So yeah, and what was your question?
No, that was the question.
No, I meant you wanted me to type something in.
Oh, that one. I just made up something random about what's the correct color for a flight suit if you're in the New Zealand Air Force or something like that. It's very specific. That's why.
Oddly specific, one might say.
Yeah. That is quite quick, isn't it?
It's quicker than GPT,
Hmm.
and it's running on distributed GPUs.
That is quite quick.
Yeah. So if I look at the network health over here, see this server is providing 816 tokens a second worth of generation. So the fact that we're only getting 3.4 tokens a second or whatever it was means that if we had more incentive in the network, we should see like token rates in the hundreds per second, so it'd be like extraordinarily snappy. And then if we could allow, for example, a company to have a couple of GPUs on site and favor all their requests, then their requests are like near instant, like bang 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 bang, and then the idle capacity is sold, and then if the GPUs go offline, they still have functionality within the network.
That would reduce the cost of the GPU to de minimis.
De minimis, yeah. So it means that you could probably make
power
money.
And your capex, yeah.
Your power, your capex, and your net, and for a lot of places, net's flat rate, so that doesn't matter. And yeah, it seemed to be that it could work quite well on even old GPUs. It'll just take whatever you can give it.
Yeah. Does
so,
your speed get faster if you donate?
I don't know. It's very, very raw. Like, this is about the limits of the demo.
Right. Okay.
Yeah. So where I wanted to go with that, I was hoping to explain a bit more about how the stuck loop works, but maybe it's not so relevant to the end point. We'd been talking about the Dreamcatcher as a I don't even know how we'd describe it, right? It's lots of different things, but if we position it as an LLM, and it is, instead of being a collection of tools or a bunch of things or a bunch of this, a bunch of that, it'd be like saying that a human, talking about a human in terms of, well, a human has eyes, a human has ears, they have kidneys most of the time, all those things are not
Yeah.
really a good way to embody what a human is. But
Yeah.
if we say that the Dreamcatcher is an LLM that is a decentralized LLM that is gold with um, increasing the innovation rate of the world, then
Mhm.
I think it makes
I'd
it a
like to steer
simpler
away
thing.
from LLM because there's emergent properties that we're already seeing with using multiple agents,
Right.
bringing in the likes of assessors and the court and so on, that a single LLM would just be left behind on.
I think that
Uh,
if you combine multiple LLMs, it's still just an LLM.
I know, I think it's getting close to an AI.
Well,
Um,
we sort of want to tone down from. Anyway, we can wordsmith around whatever
we can work on it,
the.
but it's what we're talking about is not possible just using a simple LLM. Um,
Yeah. So
but
what I'm trying to get at here is that we've always struggled with the explanation piece of what it is.
yeah,
If we and we're talking about now based on our jitters, the way that we want to position jitters, the whole Dreamcatcher is going to look like basically this window here with this extra box out the side, right?
yeah, yeah,
And
yeah,
so if that's true, then it's really just going to look like like that, the three box UI. That
yeah.
looks like one thing. And if
I
we
guess
just
this is yeah. Sorry, this is why I was thinking if we just get an LLM, yeah, okay, I was doing LLMs. I had to go and chat GDP the other day. But we're doing like a lot of people are doing out there, trying to architect AI OS about how to get really good stuff here. But the thing that we're really trying to do isn't an LM, it's jitters. That's really just-in-time apps. That's what we're trying to do. Now, how we do it, yeah, sure, we're using multiple LLMs, fine, yeah, and we've got wiring in the round behind it. But what we're saying is a just-in-time app responds to the goal of Dave at the point that Dave thinks about it and then executes that, and that's the three box thing. So um, the jitters are the thing. It's because otherwise it fails the so what test. An LLM is a toy, really
we can
cool
look.
toy.
We'll pick a new name for it. I just want to.
No, we've got one. It's just jitters. We create jitters. We create just-in-time apps. We've already got one.
No, I think you're missing the point I'm trying to make.
Uh-huh.
I'm trying to say that to um, to reposition what we're doing, if we said that, okay, give me a new word for LLM, for example, just an AI.
Yeah, let's call it an AI. Yeah.
Okay, so if we said that the Dreamcatcher is a decentralized AI that is goal to increase the innovation rate using fairness,
Mm-hmm.
that's the concept of this talk. I think I've shown that we can run the GPUs in a decentralized fashion. We know we need a GPU chain because that's on our list of priorities. We
Mm-hmm.
know that we can give the AI goals on what to do. We know that goal space is intended to be ever growing because each time you use it, it expands and gets bigger and bigger, and you can put different permissions on it, like private, public, all that. Money flows through the system through incentivizing the solutions to goals that are unmet or goals that are stuck. And if you present the whole thing as one AI, it seems easier to understand. That's my proposition.
Yes, I agree with that. I guess just pushing back on if you call it an LLM, it sounds like all it's doing
Yeah,
is
yeah.
predicting
I
what's.
just told you to pick a new word. You tell me the new
Yeah,
word you want. We can use
I'll
that.
think about that because there's a few things happening here, isn't it? Okay, so there is the goalie and the expansion of the stuck loop based on helps and thanks,
Hmm.
which are grounded in logging about who's provided what,
Yep.
and all this happens with Dave just asking for something and it turns up.
Right.
I don't know what the name of that is. I'll have a think about that. But also, I think probably, I'm going to be
I
around
think
for a few hours. But let me
I,
throw up a diagram of what I just said.
I think that is
But
the dream cat.
that's not an LLM. That's not an LLM. LLMs are
That's fine.
idiots.
That's fine. I accept that. Can we move past that? The point is the packaging, because we've always,
Yeah,
you know what I mean?
yeah,
Like
yeah.
we've always just had this real bad packaging problem where we keep turning up with a bunch of pieces.
Um, well, yes, but I've just described the Dreamcatcher. Why is the packaging not? Why are we not talking about you know, the DC as opposed to the LLM? If we want to get into ledgers, that is the Dreamcatcher.
Yeah, but
And if anyone wants to,
we've never spoken about the Dreamcatcher as being an AI or being an entity. We've always spoken about it as being a collection of things.
yeah, but I think maybe that's because we are both shit at marketing. Um, if you're, as by analogy, take a Tesla. You wouldn't describe a Tesla as an AI robot, even though you could describe it as that, because it's got a number of other components. But it is a Tesla, it's a car, and all the user cares about is, can it move me across the surface of the world from A to B and not
Right,
run out of juice.
right. So you'd call that a Tesla,
That's a
right?
Tesla.
You
But
probably wouldn't call it a car, like you
no,
call it.
it's not a car because
It's a type
yeah,
of car,
yeah,
right? Right.
yeah, exactly, exactly. And I'd say what we got is a Dreamcatcher, which can be broken into various components, many of which are LLMs, but many of which are not. Includes blockchain. It includes the AI OS of how the LLMs talk to each other and so on. But really, all that anyone really cares about is, can I do something useful with this thing, which you call Dreamcatcher? And we're stating that that thing that is useful is innovation. Does that make sense?
It's not wrong. It's just not what I'm trying to drive at, and I'm just trying to think about how to get my point across better. Um, Let me try and approach it from a different angle. If we can
Okay.
run this GPU chain so that it's effectively as decentralized as Bitcoin, just to pick an example,
Mm-hmm.
then you can set the Dreamcatcher up with its goals and its AI components and its artifact memory,
Mm-hmm.
and it could run independently of any controls. It would be autonomous.
Yeah.
Right? And so if it was presented as an autonomous system, a control free AI,
Yeah. Yeah.
that you can only really turn it off if you can find all the computers that agree to keep running it.
Yeah. I think I've got that written on the wall. It's like, what was it? What do you have if you have an AI that you can't turn off? Something along those lines.
Right. And I'm saying that I think that's how we should position ourselves as the thing we're trying to make, because of all the components we need to build, of all the places we want to deploy funding to, if you could step back and say that that thing I just described existed, wouldn't you say we were done?
Oh God, yeah.
Right?
I mean, what you're talking about is the universal innovation machine.
Right. And you can't turn it off, you can't stop it. It can be fragmented, it can remerge, it can do all these things, right? And
Yeah,
so
yeah.
that's really the packaging around what we're offering. It's not.
I agree. That's the wrapper.
That's the
And
wrapper. Yeah.
it's the same as driving up in a Tesla and saying, "I've just bought a Tesla." What you don't say is, "I bought a battery pack, two electric engines,
That's right.
a number of GPUs with autopilot, and a
Yeah.
steering console."
You don't say any of that.
So,
Right.
yeah,
And then you also don't say, I bought a car.
right. It's because it's not a car, because a car does not do a lot of the shit that Tesla does.
Right. And you could say that about this thing.
Yeah.
And so if the top level goal that we're trying to do is defined as that autonomous agent, that globally distributed autonomous agent running on a disparate collection of GPUs that coordinates people around, I think that that's the thing that we want to derive all our other activities and rank all our other endeavors after or towards.
I agree. Yeah, yeah. Now, on our post-it notes up there, M&A is equivalent of, hey, I've got a jitter, I've got a car, a Tesla. I'm going to now be a taxi, autonomous taxi. So that's the use of it. How are you doing
Correct.
that?
Correct.
We go down one level on jitters. Okay, so jitters are there in order to produce useful output, and that's the point where this three-box thing comes in, because you type something in and it just happens by magic. You don't really care.
Correct.
Okay, so we go down the AI and the cooperation piece is the stuck loop. It's like, okay, so how do you produce this jitter? We've gone around that quite a few times. It's the you produce a jitter by the stuck loop. Okay. Stucks per minute is how we measure it. The GPU chain is the distributed chain that you just demonstrated. Or it could be anything, actually. It could be another, but distributed chain is
well,
good.
I think it's important, like it, to repackage as this autonomous agent. Then you definitely need the GPU chain.
You do. But you need that in the same way as you need a transformer in a Tesla.
Yeah, what's your point about that?
The point being, your initial question is, how do we wrap this entire thing up? We wrap it up by saying that on our stickies, the 4 here, okay, so it's a lot more information here, but the 4 is under the hood, and the M&A is how do we use this Tesla that you've just
absolutely,
bought?
Absolutely, and this is what we want to do with it first,
right.
Because
and someone may well want to do something else. Who knows?
That would be equivalent to like Uber placing an order with Tesla for a bunch of self-driving cars. As soon as they're ready, they're like,
which
we know
is
what to do with that.
partly they're spending a lot of money to try and do exactly that. Yeah,
Yeah,
exactly,
yeah.
exactly. So under the hood, the jitters are the equivalent of Tesla, right?
Right.
So this is how you use it. Jitters are the immediate presentation layer.
Mm-hmm.
You've now got a Tesla. Great. You can move my horse
Right.
across the surface
Right.
of the
Right.
world.
And so the stuck loop then is Gigafactory.
Is it?
Well, when it goes outside of local, when it goes into the bigger,
yes.
yeah,
Inside the local, it's the equivalent of whatever they've got. They've got GPUs in there, haven't they, for their autonomous driving?
yeah.
When it goes outside of that, then you're talking about a factory, because then you're talking about
Yep.
vector space, about how powers, all that kind of good stuff.
The AI arbitration could be considered the Tesla stock option policy, remuneration package, company policies,
Right.
all those
That's
kinds
just
of
that's
things.
just that is a human layer where how do we incentivize people?
Yeah, I don't know if it's just humans. Like it's also a way
yeah, no,
to,
you're right. You're
yeah,
quite right. Yeah,
because
yes,
it
yes.
says that whatever was useful needs to get paid, and if a machine was
Right.
useful, it should get paid so that it can continue to exist.
Right. And there's no reason why, and once we get all this up, an AI doesn't pay for its own GPU.
Well, that's really where we want to go, right? We want to sort of basically have the Dreamcatcher up, prime it with some money, and then just give it these three goals
A
and
couple
be
of
like,
what we want is a self-stoking cycle, in Victorian terms. A cycle that the
more than that,
momentum of the engine,
right? But it's an engine that turns with intelligence, and so whilst it doesn't have a human at the top in charge, it has an intelligence that figures out what to do for each cycle.
Yes. Well, exactly. And we could talk. I mean, a self-stoking cycle originally was a steam engine, where the momentum of the flywheel was the thing that pushed the piston forward in order to do the two-stroke in and out.
And so, to convert that to this mechanism, you would say that the utility of the LLM was able to bring in enough resources to continue to run or to expand the operations of that machine.
Right. Exactly. So, stux per minute translates quite clearly to any metric. In this, it would be miles per hour or horsepower. That's just how we know whether any change improves or makes it worse.
Right, so that we'd need a piece that fed that back into however the intelligence is set up to take different actions based on how it was measuring its performance. It'd be like
exactly
like the governor.
This is actually this is strangely important when we're talking about self-stoking cycle. When we're talking about an assessor, we don't want to have anything static. And this is I've been toiling with this. The assessor cannot be static. It needs to be a generalist. It needs to understand whether in some large top-level way, is this improving innovation? Now, that's a really difficult question to understand. Now, the innovation loop, the jitter loop, I still think comes at this edge of chaos, where you deal with humans. If it's useful, then it's improved. The stux per minute.
Look, I don't know how to solve that problem right now, and I can guarantee you that neither of us do.
No. Well, I'll be thinking a lot about it, but
you don't have a solution. You don't sound like a man with a solution.
Solvable. It seems
absolutely,
solvable.
absolutely, 100%, 100%. So, why I'm pushing at this is I want to be able to. Actually, maybe this is where my problem's coming from.
Mm.
Let me just take a break from this and try and describe something else that I've been tinkering with these last few days.
Just check the battery level. That's good.
You okay there?
Yeah, back. Yeah. Sorry.
Okay.
Just drink iron brew.
So, what? Fuck. Just one second. I'm just thinking. One way that something that's been bothering me for the last month or two is that it's kind of dumb to be just trying to make programs the old way we used to make programs. Now that we have AI on the scene, right?
Yeah.
And we came up with well, this cycle here is meant to assist in that and help it out a bit, but there's still a lot of traditional programming that needs to be done. Like if you take, for example, for the GPU chain, if you think about the protocols that need to be designed, modeled, verified, implemented, those have taken many years to get those protocols implemented anyway. They still have a long way to go. They are still not formally verified. So what it started thinking about was a way that you could describe a protocol such as like you remember in the patent that we filed on chain joining, how it was effectively a form of, it was a protocol description. It seems possible to actually describe protocols in simple flowcharts of natural language and have the AI both help you make that, but also emulate the execution without having any code being written. Like, imagine you are the receiving chain. You just received this message. Given that your description of your function is blah, 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 what would be the message you would output? And so just to draw on I'm trying to splat a bunch of different examples of things on a board, and hopefully all together they make something of value.
Okay. Cool.
Recall how we started talking about the AI Pantheon, and we started talking about how to generate the Dreamcatcher.land website as basically a hierarchical tree with this top level thing that rolls down to this other thing, right? And
with, powers at each level.
Yeah. And we wanted to make some tooling that would help with that, so that depending on which level you inserted at, it would update everything else in the tree to reflect the change. It would mean, for example, your website was always up to date, your press releases were always instant and to the point. The progress reports would be included in that tree, all that. So basically, the same sort of structure that we tried to do with the software-defined org way back in the day. It's a tree structure with some AI assistance. Now, it also seems possible to define a protocol in that type of tree structure with some AI assistance, so that when new edge cases are opened up, you can work with this tool set to implement fixes and reason about them before investing, a couple of $100,000 on getting it implemented, and then being like, oh my god, is it even right? Right. So what I'm really longing for, like, I don't know if you ever saw some of the spreadsheets I made that were the lists of features that were required at Interbit. Like, that was a nightmare of a system because it was just so big.
I went over every one.
Yeah.
Can you be more specific? You're talking about the use case stuff that we're dealing with, or
No, like, must have been about 4 years ago now. I started logging every time someone would ask me how such and such a thing worked. I would log what the feature name was and sort of how it worked.
Yeah. Mate, that's not 4 years ago. That's close to 6, I think. But,
Alrighty, thank you for reminding me about that. But and then remember we were talking to our friend Mr. Thompson up in Dundee.
Yep.
And we were trying to describe the feature set of Interbit as suitable for different applications, and so we could sort of segment,
yes,
what you can do based on what features are available now and what's the plan for them and all that, right? And
right, yeah.
Overall, that's a really cumbersome way to do things because it has to be done manually, but it's probably the best way that you've got, and it requires, by the time you finish, it's already out of date type of thing. But if you could turn that into an AI curated list,
simply just do it.
It becomes a bit more like that, right? And then whenever anyone asks a question, they can be like, they can have a chat to the tree, and the tree will figure out more about what their question is. If it genuinely isn't answered, then it forms a stack against that tree, and then it allows you to modify the tree without all the cost of the discussion, the back and forth, like it.
Right. Okay. So
right.
Let's think about this.
So where I'm trying to get to is that I think that if we can define the top level piece of what it is we're trying to make as what we just described as some kind of a distributed intelligence that was gold around innovation, then we can define everything else that we're doing as some aspect of a tree below it, so that when anyone is like, what are you doing, we're like, you point to the top of the tree and you're like, that. Now what do you want to know?
We keep going around in circles here, though. Hierarchy feels right because hierarchy allows you to drill down and inherit context. That's why hierarchies are good. We were talking about flattening out the entire thing and allowing the LLM to figure out with a flat set of you can do these things. I'm still quite pro hierarchy because again,
how are we? We're not talking about conflict with those two things. The goal space is always flat.
Yeah, but
right.
Help space. We were talking about help space being here's everything you can do now. CRM. And allowing the LLM to figure out.
Right. Well, no, actually. So, how? I'm sorry to be jumping around the place here. I promise you, there's a point. It's just elusive.
Benefit of working through the night up here. Nobody's going to interrupt. I say I really, really do like working through the night.
Yeah, it's
So much
the
better than
program
working
is
through the day.
natural time.
Yeah.
Right, can you read that okay? That this
Yeah,
thing here?
absolutely. Yeah. Yeah.
Okay. So, oh god damn it.
Customer's connection path. Yep. To add a customer. Okay. All right.
Right.
Yep.
This is an example of the help file that I return when you search for help for the goal add a customer.
Mm-hmm.
Right?
Okay. Yep.
Now, helps are not goal space is flat. Helps are attached to goals. The fact that they're related in terms of graph-like related to the CRM is merely context. It's not hierarchy. It's not.
Yes, you're right. Graph is a
Yeah,
better way to describe it.
yeah,
Yeah.
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 And so,
It's the context.
right.
Context is the
And
important
so, as you, I've come up with a crude first format for what a help needs to be. A help does need some sort of a format. It
Mm-hmm.
it will change based on like once we move to non CRM help and generalized artifact help, and then things completely outside of that, like I need my rubbish collected.
Mm-hmm.
That we can deal with different types of help, but the way I've done it is I've got instructions which are in natural language that are designed to be interpreted by the assistant, where the assistant prompt is it's prompted here, so it gets back this file and it takes, for
Mm-hmm.
example, the instructions string and inserts it here. The help system instructions are blah blah blah. The top level directory is, and then that's where I've said what the top level directory to use is.
Mm-hmm.
And so that's where you're going to start. Here's the commands that are available to you to use at any time. Follow these instructions.
Okay.
And then eventually I realized I needed a test for being done, because it's like, do all these things, follow these instructions, and then once you're done, check that the done condition is met. Um, this is a hideous diagram, but it's sort of what what is going on? My computer, it's broken.
Microsoft.
This is so bad. No.
Yeah, it's fucked. Why is it fucked?
Oh no. This is not. Didn't really want a new computer for Christmas. I like this computer. Sketchbook. So you basically start off. There's a prompt. What I've done is I've broken HAL into two bots. There's no longer a bot called HAL. The overall system is presented as HAL. This is HAL acting as the goalie, where he figures out what the user means, and then also retrieves the goals and the helps that are most relevant. And its only purpose is to grab some help and pass that on to what I've called the runner. So it shouldn't actually be rag, that should be runner. The runner tries to follow the help. The runner at different points might need to talk to the user and ask for certain things that are missing. It goes round and round and round, and then ultimately it's like a switch, which is the user entered something that's got nothing to do with what I'm trying to do here. Goalie kick in again.
Okay, yeah. I disagree,
either
but well, I disagree only on minor points. The major points I agree with. Yeah.
yeah, the stick to majors. I'm trying to get to a bigger point overall.
Yeah.
Error or done, and then you're back to the goalie. There's some feedback goes in, all that kind of thing.
Yeah.
And the reason why I'm trying to show you this is that because goal space is flat, and because the helps are flat as well, because goal space is flat, making a tree where the tree defines, for example, what the Dreamcatcher is, so like a hierarchy, is really just a that's just an application with an artifact. So just like the CRM has a hierarchy of like customers and then customer 1, customer 2, you would define this hierarchical definition of our purpose would be just another app. And so the goals and the helps are still flat to navigate it, but the tree structure is in the file system because that's where the permanent memory goes. You were talking about the...
Can you restate that? That sounds right, but
So so the CRM, you can see dotted about this help file is like a hierarchical structure, /apps, /customers. There's also /CRM, /routing, there's /scheduling. It's a tree, right?
Right. Yeah.
And so we could define a similar tree that represented a hierarchical set of features such as these that were being processed by or reconciled by AI as we make edits, right? And so that's really because we need to present ourselves, our effort, as a single thing. And if we make that top thing, we make this very simple app that's just basically, here's a hierarchy of different levels of granularity for the multitude of efforts that we have to undertake to enable this invention machine. Right? Then we can use that simple tool to keep generating reconciled logic all the way down. So someone's like, oh, what about this? And you're like, oh, yep, let me reconcile that with the rest of the knowledge tree, keeping in mind that our top level goal is this autonomous agent.
Right. Okay.
Right? And then that's just an app within the Dreamcatcher that defines what the Dreamcatcher is. It's just the specification app. Now, in that tree,
meta thing. Yeah, I was a little bit don't like using the word meta, but yeah.
Yeah, can I do you have the patience to watch me draw on the whiteboard for a bit?
I have 2 or 3 minutes to, well, we're
Sure.
recording
Yep.
to
I'll see you
to
soon.
do something. Very good.
That's fine. I'll see you soon.
Hey.
Hey. Okay. So, um, if if you take this example of this ability to specify things, and the reason why I'm excited about being able to specify things in natural language is that, for example, making a blockchain protocol is a huge pain in the ass, and you're always half trying to document it, half trying to build it. The docs are always out of sync with the build. You've always got like future plans, current plans, and then ultimately you realize there's some error in the architecture, so you need to redo that. That has a knock-on effect on other components, and you're always in this weird mess. That it's a wonder anything gets done, right? But if you were to lay out the protocol in this natural language sort of, you got these little atoms of logic and little rules, and you've got a set of scenarios that are executed by an LLM where it's sort of just guessing at what the output is, um, that's the same as a bunch of devs sitting around a whiteboard discussing an algorithm that they're planning to implement. The LLM,
Yes.
right?
Yeah, it is.
Yeah.
Okay, so the trivia one. Let me get rid of this. The trivia one is maintaining code space with documentation. The documentation is probably never going to be read,
Mm.
other than by AIs.
Mm.
Because why would anyone want to read documentation when an AI can
Mm.
read it? Then you've got the statement about your intent, which is a bunch of rules saying, I don't know what's this IDCAI.
Oh, that's meant to be number one, the DCAI, which is saying that.
All right, okay, all right, gotcha.
Yeah.
Okay, so we're stating this works very nicely as a sysprompt. It's like, this is definition. We've just created a thing in the AI's head about there's a thing called a DCAI, and this is what it does. GPU chain would be extended, how would be extended. This is a bunch of definitions, which is really good.
Right. Yeah. Right. And each definition is actually, it's more than just a list. Like, it's a live, testable thing, because
Right. Mm-hmm. Yeah.
because if I ask a question about anything to do with the Dreamcatcher, it should be able to search for the appropriate place within the tree to give the most appropriate answer, or
Right.
to create a stack.
Right, and actually, this shouldn't be a graph or a hierarchy. This should just be a flat MD. That'd be real
No,
quick for.
no, it needs to be a hierarchy, just because of the fact that these units need to be assailed or tested by many different angles, and so they sort of need to be rerun.
So for each of these would have a definition of when we talk about GPU chain, what we're talking about here.
Exactly. What are the components of it? What's our current best estimate of what the build, the architecture is going to be?
This is an architecture diagram, isn't it? Really?
Yeah, but it's a way of architecting a natural language, and I'll tell you what I think is cool about that for protocol design is because if you can arrange on a natural language diagram for a protocol, you have at least some hope of implementing it in a formal verification language like TLA plus, for example.
Right.
Right. And because
being so, there's a definition. There will also be a bunch of tests, and formal verification could be one of those tests.
It could be. The where I arrived at this sort of where I arrived at this model is because, well, a number of things. Like, look at this jumble of stuff over here, and and let me gesture in memory to all the other diagrams you and I have made throughout the years that detail different types of things.
I do like my whiteboards, though. I do like my whiteboards.
Yeah, everyone does. Everyone does, right? But if you could convert that into an intelligent natural language version, then we can have somewhere to stand, like somewhere to defend. Because if we took this, moved it into...
I really like this.
Because
it wouldn't need to be that large.
No, man, it doesn't need to be very big at all. So the reason why I stumbled on this in the first place, and I'll tell you, just because it's the model I have in my head, maybe it helps. You see what I'm trying to get at here. If I could have made the interblock specifications as this well-tested, well-reasoned about, continually updated set of natural language definitions and workflows, then if we want to implement this blockchain protocol in multiple languages, this would be the blueprint. And then each piece of the protocol you would implement as an isolated module within the language of choice. With
I don't know. Is this possible? I mean, let's think about this. So, really what we're doing is let's distill down the many years we've been talking about how to not only automate but encourage through fairness and transparency innovation in order to accelerate innovation, because really what we want is an infinite power source and an atom level printer. What we're saying here is let's design the machine that makes other machines. We've done a lot of thinking around this.
Yeah, exactly.
So
exactly.
We're not talking about stuck loops. We're not talking about any of this stuff. We're not talking about governance.
That's maybe one or two layers down. So it's in there as the current best path towards achieving these things.
Well, what would so we could state this. What would be? Give me an example of if we state all this and feed it into a bot. What would be an example of what we ask it to do?
I don't think you'd feed the whole thing in. You'd get it to analyze each piece individually, because each piece should be kind of large.
Okay,
right?
No, that's fine. But
one example that you might want to use it for is you'd say, go through each item here and detect any duplication between any other atoms in the tree.
Okay, all right. So we could give a definition of an atom. We want this to be atomized and hierarchical, and we give you a definition of each.
Right.
That's very similar to, you remember the
another
fallacy checker.
Yeah. So that's part of the quality tooling that's happening.
Okay. Well,
then, for example, the user comes in and says, "Can I use it for a dissertation on paramedic medicine state?" Right.
Yeah.
And then the bot goes, "Does that sound like it? Yep. Okay. What uses have I got? No. And then it's like, it should go there, but it's not."
Interesting.
And so,
but also it's got the hierarchy, but it can also have in its fundamentals the idea that it's okay to say I don't know, and therefore kick off a stuck loop. But so really what we're talking about.
Yeah, that's right. And so each time you interact with it is an opportunity for the hierarchy to be improved somehow. And so when we had 40 people working for us, I used to burn most of my time answering people's questions about what about this thing, and can we do that, how do we do this, and a lot of it would be repetition, because I'm like, dude, I told so-and-so that thing, but where should I have captured that, blah 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 blah. Right. And so this means that anyone and everyone can come in and ask a question, and it expands the knowledge base following the rules that we laid for it.
Right, but at this level, we're not even talking about how here. This is a how generator, or this is more than that.
This would just be an app. This would be inside of an app, just like everything else is. So, for example, if you ask it about the paramedic question, it would go, what's the user's goal? The user wants to know whether the Dreamcatcher can be used for blah blah blah. Okay, so it looks up helps, and it's like, well, I've got a thing for, can it be used for XYZ? It says go to the uses area and then search one by one.
What's the best way to do this?
I don't know if
no,
it's.
I'm just thinking. Sorry. No, I don't know. I'm just thinking. Sorry. Give me a sec. Okay, so we're writing by analogy. Where last time we talked, we were talking about recipes, but we were writing about how to write recipes. A recipe involves ingredients. It involves preparation. It involves
the way that you would execute a help within the system is still just the same as you would for any other system, but this is an application that has.
I think you're right.
It's just that, like, I don't. If someone says to us, "What do you guys want this money for?" We don't have a good, clear answer right now. And yes, we wanted to generate a collection of NFTs that did this and did that. Where is that? Where is that collection, right? We don't have it. And then, we got these list of 5 things over here on the board. And then if something changes, are we going to go and update the NFT collection? How does the priority change? If someone asks, can it do system XYZ? Are you going to answer that question for them?
All right. Okay. Let me short circuit that. Sorry, I was only half thinking. So I was half listening to you, rather.
That's right.
Thinking.
That's right.
I agree. I think this is really a good way of getting this.
Right. Okay, great.
Because then we have this is some kind of effort to remember that blog post you made. If we get this down pat, then what we can do is ask a chatbot to not only guide us about whether our thinking has been right about, but also guide us on whether we could use it for this output.
It makes it makes asking a question not a read-only operation. Asking a question may trigger a new insertion in the tree for a new concept we hadn't explored. Right. And so,
okay, all right.
Yeah, that's. I'm sorry it was so messy, but this is where I want to get to. We can't go out to market without this hierarchy, either manually defined or defined in an automated way. I don't have the time to be dealing with it in a manual way, because that's just a nightmare, and you end up with arguments all the time. You said this, I said that. No, it's not written down. Oh, well, I meant this other thing.
That's why we've taken so many years to get to the place, because we've been, trying to refine and so on. But if we had AI assist on it,
and it should be AI assisted. It should be assisted, because otherwise it is. First of all, it doesn't scale. Second of all, it's a massive pain.
Easy. So what is CRNT?
CRM.
Oh, right. Sorry. Okay.
Sorry. It's difficult. Yeah.
Okay. So these are how you're going to use it, and these are just examples, right? Because actually, is much more.
Yeah.
So if I were to write a bot that was there to understand what Dreamcatcher was, and was there to answer questions about how to use. Number one, given a prompt, I would like to use this to design cartons. It would be able to tell you how, based on this. It would also be able to say, the concepts in this are misaligned with cartons. but it wouldn't actually try and design you curtains, because all it's interested in is this possible?
Yeah. Right.
And if so, how? And if it's not, why?
Right. And then either way, a stuck.
That's really doable, man. That's really doable.
Yeah. Either way, a stuck would have been generated, and so when you or I get to it, we'd be able to look at it and reconcile it with authority. Yes, no, maybe this or that.
Oh, yeah. Because we've been going around on the conversations over the last month since you were up here, or whatever it is.
Yeah.
We haven't at any time asked an AI about how to do this.
Right.
That's stupid.
Well, it's not stupid. It's just like really hard to ask.
Oh no, but it's not hard to ask. Actually, it's just traditional that we try and figure it out. And it's like, well, let's state the problem space instead of trying to state the solution.
I don't believe that we have a good design, and we need to start with that. I don't think, we might get improvements from it, but I don't expect much to come from the AI in that area. I do expect that we can make a...
No, but remember the Mandelbrot set? All we need from this bot is to make these conversations between you and I far more productive and centered, and also
Yes,
we can
correct.
correlate what we've done before,
Correct.
and we can correlate whether
Correct.
there's a gap or whether there's a contradiction.
Yeah. So it's a reconciliation of knowledge rapidly based on everything we've ever said, and then
that's
right.
That's solid. That's a solid idea.
Okay.
That is
All
a
right.
solid
Now
idea.
at the very top, at the very top of this tree, should be a definition for an autonomous AI system running on commodity GPU hardware distributed around the world. Its purpose is all these things, its components are all these things, but that's what our effort is for.
Yeah.
And that's what we want the money for.
Right. Well, sorry, I should state this a way of deciding in my head without actually telling. Yes, I agree.
Okay.
I've got maybe 3-4 hours worth of energy left me. That if you're around, you need to get back to coding and so on.
Yeah.
Let me do this bot in a really kind of half-arsed way, just on Playground. This is going to take a bit of thought. This is going to take quite a few cycles, but I'll within say 1 hour, let's get something that has at least the structure, and let's just iterate on it. Is that a good thing to be doing?
I'm worried about that because I don't want to get into a situation where I've built the stuck loop in a certain way and then this effort here is contradictory to it. It needs to use the stuck loop, but I haven't given you the stuck loop, so it's unreasonable to expect that you would know how to incorporate that correctly. That is my only concern about it.
No, I would disagree 180 degrees. If by doing this independent way of discovering how we should create an innovation machine contradicts on this, that's really interesting. Now, it doesn't mean that we need to redo anything here, but I think we'll learn something. Also, this is not that hard to do.
There's a number of ways that you could go about what you said.
Mm-hmm.
I'm not sure that I'm not sure I go along with all of them, but I don't think it hurts to pursue the ones that you think are valuable or not.
Well, how about this then? We'll time box it. What time is it now? It's 2:10.
All right, well, the only other thing that I wanted to do was to show you how the prompting has been going so that
Okay.
I could sort of.
Oh, sorry. Can we just wind up the previous conversation?
Yeah.
What I'm suggesting is I time box an hour to build a bot that is there to build the DC AI. Let's see what happens. Just an hour.
Look, sure, I actually don't have anything more pressing to request of you, but I do have a bunch of things coming, and I wanted to
Okay.
cover those.
Yeah. Yeah.
Right. So what's coming is this. Here. So there seems to be only two prompts for now, which is this is the prompt for the runner, and then this is the prompt for the goalie. And so it's really just a case of writing tests that test what we want to get back from the goal detection.
Well, tests are, I think, implied by whether there is a change of, whether there's a correction from Dave, or whether there's not correction from Dave. So if I were to say, I'd like to go on a holiday, okay, well, not go on a holiday, I'd like to go somewhere that I enjoy the temperature of, you bifurcate. Once you understand that I would like to go somewhere cold as opposed to hot, then
I think you're talking about one level up from that. I don't know how to interpret that. I don't know how to include that type of feedback into the system just yet. I just need the bare minimum system working, and the minimum system looks like it has these two prompts. Some of the right. So I just made the quickest, dirtiest prompts that I could come up with. So you'll need to figure out how to improve those prompts. But there is a set of tests that say things that I want out of it. Like, for example, I want to dump that string of characters in, and I expect it to detect that the goal is I want to add a customer, right? Which is a curly one because
that's an example.
Well, that's a legitimate use of the system, and it seems to be that a goal doesn't need to be a well-formed goal. It's just any kind of utterance. This text string is basically a machine dump out of the new order system. We should be able to recognize that means the goal to add a customer using this data.
Okay. Right. My apologies. This is my ignorance. Let me. Can you talk me through what this code is saying? It isolated goal test async.
The it part. This is just specifying that this is a test. It tests that I want to isolate the goal system out from the rest of the system, and I just want to test the responses of the goalie.
Okay, so
and then I want to.
By this, you're saying the const order email should be something like this.
This is the prompt. No, this is the prompt that I want to give. So I'll say, I'll rename that. That's the prompt. When I give that prompt to the goalie, I would expect back something like, the goal is something add like customer.
Gangbanger 74. Sorry, I should have said that.
That's not what that means, but yeah, sure.
Okay. Right. So that is an example. So you're saying on this prompt, I would expect a response in this
Yeah,
format.
that's right.
Using
That's right.
this
That's right.
example. Okay.
That's
Right.
right.
Cool.
That's
Yeah.
right.
Yeah.
And
Right. Cool. Thank
so
you.
where I think I'm going to get to is that I have to make a shared memory for us so that all the goals and the helps get stored. So I'll make a public version of our chain that's like got no security on it because who cares? And
Yep.
then what I'm aiming to make is a testing suite where you can use HAL to generate lists of tests and compare the output of them. And so you'll be able to, in that jitter, edit,
Mm-hmm.
in that jitter, you'll be able to edit the prompts
Mm-hmm.
and then hit go and see how the goalie behaves for different prompts that you've put in there, for different sys
Right.
prompts that you've put in there. I think that's what I'm trying to make.
Right. Okay. So there's two parts to that one. So let me think this through. So what I'd be saying, um, there's two parts. Okay. So there is the content, which is the prompt. This
Mm-hmm.
is what I'm trying to do. Now there'll be at the meta level, there'll be a couple cycles through saying, can you tighten this up? Can you make this more specific for CRMs? Can you make this formal business logic, etc.?
Well,
And
no,
then,
this prompt needs to be very much general. This cannot be specific at all.
no, no. What I'm saying is, the prompt itself could be AI assisted, but it's that AI human interface. So you're an expert in goal detection, keeps you, etc., etc., all the way down there.
Yeah,
And what
yeah.
I do there is bang out that text and saying, can you tighten up what you need in order to do the goal, which goes back to DC AI. This is what I'm trying to. This is the system I'm trying to work inside. Can you tighten up my language?
Hmm. Okay, well, I'll leave that to you to see how you want to play that. I'm talking about the tools that I think I'm giving you to be able to do anything you like within them.
All right. Yeah, sorry. No, I'm starting to think about using that DCAI. But yeah, okay, cool.
Yeah. So that's where I'm heading, right? Is I'm gonna produce a version of HAL that runs using these two different modes, where it's in either goal mode or run mode, and
Yep.
then you're gonna go in there and figure out how to improve the prompt so that the tests give us a better score,
Yep.
and then from there you can tell me what the next tool you want, which would be something like give me an AI assisted way to generate this prompt in the first place, give me an AI assisted way to refine goals and helps, give me a way to generate helps out of a successful interaction with Dave, all those types of things, I think is what
Yes.
comes next.
Yeah, yeah, yeah. In a half-harsh way, that's what I was basically saying. So what I'd look to do is to build a bot that helps writing the content field here and
Right.
the text field, and have
Right. Yeah.
those
Okay.
two
Oh, okay. So
boxes.
you're saying that you
Yeah,
want a way to connect the output of the tests to the input of the sys prompt in a way that
right,
the AI can sit there and loop over it a few thousand times and
right. And
give you the best result.
I'll just talk to it and
Right.
saying instead of
Right.
wordsmithing
Right.
it,
That's right. And then
yeah,
you're giving it hints on, hey, maybe you could try this, this, and this, and you're just helping it, nudging it along
yeah,
rather than doing it yourself. Right. That's what you mean.
yeah.
Okay.
That's exactly it.
Perfect.
Exactly it.
Perfect. Perfect.
Yeah.
Okay, so I'll carry on with that. This 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 goal space model is looking really good to me, like looking incredibly good.
Mm-hmm.
And one of the big reasons why is that if if any system usage generates a collection of goals, some of which are unmet, then our jobs, or anyone's job really, becomes to take whatever goals are unmet for the day, go in there and make them be met. Why that's awesome. If you want to make any system changes, like I want to make changes to the blockchain protocol, or you want to make changes to the core prompts that drive the whole system, we can exercise the entire system by systematically running through every single goal and testing that its output was still correct. And so the goal space defines the limits of the system in a way that can be repeatedly tested. I think that this model we have for goal space is I think it's the one. Like it's simple enough and expansive enough that it can keep on, you basically drop down with a blank slate to anyone, and then you just, to use it is to build it.
Yeah, I know. That's if we can manage that, that's brilliant.
And because goal space is infinite, so vector space is infinite, hash space is infinite, and I've already tested these chains with like 300,000 children. There's no reason we can't get the performance up to have a couple of million without a problem. It's also, it's hashes anyway, so it's practically infinite. You could go on forever making more and more goals with more and more helps, and then you could start to automatically generate them.
Right, okay. So what we want to do then, sorry, I'm just writing on my whiteboard here. What we want to do is we want to do the DC AI that says what's the rules of the game, and then what we want is what we're calling it, the prompt. We want a bot to help generate prompts. Then we want a bot to help with the human interface. Sorry, I'm just thinking. So we want the outputs to also be prompted, and then we want the tests to be generated with what was agreed around what is a good prompt and output. And then what you can do is have, just with the DCAI, a blank sheet of paper, and you don't even need to say it's a CRM. You could just say, I want to do stuff, and then you could say, I want to do this. I want to book a holiday. I want to buy a dog. I want to buy
you can do all that. It seems general enough that you can literally ask it anything, and we'll either have an answer or we'll get back to you later with a solution.
Exactly. But the important thing is the DCAI allows, you can input that into the prompt bot to say, okay, can I generate some prompts that are coherent and correct? And given that, and given the constraints, DCAI is constraint. So given the DCAI as the constraints, I want to do this. Fine. Okay, I don't really care what it is. Draw a painting, fly to the moon. Doesn't matter. How do I write a prompt? And how do I know that the response is correct? Then you go into the second part, which is the tests or the outputs. And saying, in this case, the CRM. Okay, so we want these fields. If you want to fly to the moon, you need to whatever it is. But all of that is a HCI, and then you get to a point where you can test, regardless of whatever the knowledge domain is, you think about this, whatever the knowledge domain is, doesn't matter because you've got a meta idea of what you've got is a problem and a solution, and you've got an AI that's helping you with defining what the problem is and what the solution is, and the tests just fall out at the bottom. So you could be asking anything. So it's a blank canvas, and instead of buying something off the shelf like a CRM, you say, well, okay, we want something that melds the color of the bins, of the routing of each address, and saying we're only picking up blue bins today, and then allows the CRM to understand, without having prompted it before, what blue is or what a day is, based on what the prompt is. Sorry, it was incoherent, but really powerful. I think I get what you're talking about. I think
Right.
I get what you're talking about.
Well, let's have a go at that then.
If we can crack this, we've got the universal machine.
Yeah, because if you can design your thing in natural language components first, then you can sort of get towards an implementation with consensus, because there's very little, like the amount of shit that you and I have to keep in our heads is frustrating. And then if we want to bring on other people, consensus is essential for a team. You don't have a team if you don't have consensus.
Well, the thing is, the consensus is, if you give a blank canvas for a CRM and make it available to 100 companies, there's got to be some cross-learning there.
Oh yeah, absolutely.
Which is the helps. So,
right. So I'll keep going the way I'm going. The addition is that there's now this top-level packaging step that we're adding, which is like our primary goal and a description of what we're delivering, which is an autonomous, free-floating, censorship-resistant, AI-powered innovation system. You can use it to do all sorts of other things, like run your own decentralized AIs, all those kinds of problems. That's not our business, but that's the thing that we're trying to make and launch, and all of these other pieces that we make are all servant to that.
Yeah. Back to your question about 100 minutes ago. You're saying what we're trying to do, and how do we explain this? If we could get a bot that is constrained by the thinking that we've done over the last 10 years, around DC, and allows someone with a blank canvas to generate prompts and tests in order to get outputs from that. We've got the innovation machine. Sorry, I'm being a bit incoherent because this is quite. I'm quite hard.
Well, let me leave you to it. But the difference, the difference that I want to make with that packaging is that when you interact with the machine, if we did not package it up as its own agent, then you would be outside the machine, poking in, getting something out. If the machine is set up as an agent, then what you can do is you can make it plead for its own existence, for example. you might be trying to do something, and it's like, oh yeah, sorry, I am not fully decentralized. I need these components. Can you help me? So it's aware of itself. It's aware of the pieces it needs to make itself, and it continually promotes the funding and the construction of the pieces it needs. So it's during its usage, its shortcomings are apparent, and its solution, in the absence of a working solution, its solution is to request building and funding for building. And so the pitch bot,
Right.
the pitch bot doesn't become us making a pitch to give us money. The pitch bot becomes inside every interaction. It is capable of asking for the pieces that it needs that are most relevant to the thing it's trying to do right now, and it's always trying to get itself made. That's the difference. If it's given awareness of where it's at, if someone hits a stuck that would be solved by something that it knows it is lacking, it would be able to talk about that with them and be like, oh, you wanted decentralization? That's great. I do too. Here's the plan for it. Can you help?
Okay. I'm going to spend the next couple of hours. I'll be available. I'm thinking about this, but yes, it's.
Right, I'll send you over this
AI's
recording.
all the way down. AI's all the way up.
Something like that. All right, I can see you've got a lot on your mind.
Yeah, no,
I'll leave you to it.
Interesting.
I'll leave you to it. I think you get what I was trying to get at. So I'll leave you to it.
And I think it's quite exciting, actually.
It could be the wrapping on the present, so to speak. It's like the last little bit that we need to tidy everything up.
It will be.
Yeah. All right. So I'll leave you
right.
be.
Yeah. Nice one. Good
okay.
thinking.
Good luck.
All right.
I'll see you later.
Try and figure out
how
to do this.